bridge pattern is a design pattern that separates a large class or a set of related classes into two separate hierarchies so that they can be developed independently from each other. So say that we have a remote for controlling radios, and there are multiple different brands of radio and there are multiple different types of remotes. So in this diagram we have an abstract class for what a remote should look like, and then extending remote or inheriting from remote is the LG remote and the Sony remote, and LG and Sony are different brands of radio. And then we have another different type of remote called advanced remote, which extends or inherits from this remote class. And underneath here we can see that we have an advanced LG remote and an advanced Sony remote. We then have another different type of remote called a mega remote, which will have some additional functionality that extends from remote. And then we can see that we have the brands LG and Sony for the mega remote. So here we can see that every time that we add a new brand, for example Samsung, we'd have to create 3 new classes. So we'd have to create Samsung remote, advanced Samsung remote and mega Samsung remote. And if we create a new type of remote, for example radio and TV remote for controlling both a radio and a TV, then we'd have to create a new class for every brand of radio. So we'd need to create a radio and TV LG, radio and TV Sony, and radio and TV Samsung. So you can very easily see that this is not a maintainable solution. So let's have a look at how this looks in code. Here we have our base remote control class, which is an abstract class with 4 methods for controlling a radio. So we have a method for turning the radio on, turning it off, for turning the volume up and turning the volume down. So let's now create our advanced remote abstract class. And this is going to extend the remote control class. And as you can see, we're getting an error here because it's not implementing the inherited abstract methods from remote control. But we can solve that by making this an abstract class. And now we're just going to add an extra method called setChannel, which takes an integer of the channel number that we want to set the radio to. Okay, so this is now our advanced remote with 1 extra bit of functionality. Let's now create our radio and TV remote. So this is another type of remote control that can control both a radio and a TV. So let's call this, let's see, radio and TV remote. Okay, and this needs to again extend or inherit from remote control, and this needs to be an abstract class. Okay, so then what we're going to do is we're going to add a couple of extra methods in here, and we're going to have a control TV and a control radio method, so we can select which device we want to control. So if we can call this method, we're controlling the TV. If we call the control radio method, then we will control the radio. So now what we're going to do is we're going to implement these remote control types for LG devices, so the LG brand. Okay, so we're not going to implement them for all of the brand types because that will take way too long. So for brevity, we will just implement these remotes for LG devices for now and not worry about Sony or Samsung. So what we will do is we will create the basic LG remote. And this needs to inherit from remote control. We then need to implement this abstract class with all of these methods, and to save a little bit of time I'm just going to copy and paste these in for now to save some time. So let's see. Okay, so I'm just logging the some different stuff here. So if we call turn off, we just say turning LG radio off. And we also need to add the volume up method. Okay, so we're now implementing all of the abstract methods from remote control. So now let's create our advanced LG remote. And this is going to inherit or extend the advanced remote class. And then again, I'm just going to copy and paste to save us some time here, because it's all very basic stuff. We just need to implement all of the methods from advanced remote control. So it's all the same as the regular LG remote, but we also have this additional set channel method. And finally, let's create the LG radio and TV remote. So let's create that. And this needs to inherit from radio and TV remote, and we can then implement the methods. So we have control radio, and we have all of the methods that we had before. Okay, so we just have an additional 2 methods here for controlling the radio or controlling the TV. Okay, then we can use this solution in a client. So if we go to our program.cs file, and let's empty this out. So first of all, let's create a LG remote. And let's just turn the radio on. And then turn the radio off. Okay, that's all working correctly. And then if we create an LG radio and TV remote, okay, so this needs to be LG radio and TV remote. And then we can control the TV and turn it on and then turn the volume up. Okay, so we control the TV. Now controlling LG TV, we turn the TV on and then we turn the volume up. So let's check that that is working correctly. Okay, so that solution is all working correctly. However, this solution is very inflexible because every time we add a new remote type, we need to create a new class for every brand of TV. And every time we add a new brand, we need to create a new class for every remote type. And the reason that we ended up with this structure is because our hierarchy is growing in 2 dimensions. So we have the abstract dimension, or the remote type, and an implementation dimension, which is the brand of the device. So we saw before that we have a structure that is growing in 2 dimensions, both the remote type and the brand dimension. So to simplify this hierarchy, we can break it down into 2 separate hierarchies. So here we have a sort of remote type hierarchy on the left, and on the right we have a sort of device or brand hierarchy. So you can see that these 2 hierarchies are connected via a bridge. So you can see here that remote control is actually composed of some sort of device, and it talks to each device via the device interface. So you can see here the remote control has a turn on method, and within this turn on method it just calls the device.turn-on. So it uses polymorphism to turn on the device, and it doesn't require any knowledge of the specific device that it is turning on because it's coded to this device interface. Okay, so whenever we have an hierarchy growing in 2 separate dimensions, we need to split them in half and connect them using a bridge. so that the two hierarchies can then grow independently from each other, meaning that we don't have to create a subclass for every combined remote type and brand. So let's now implement this solution in code so that it makes more sense. Okay, so first of all, we're going to create our device interface. And this is going to contain three methods. We're going to have turn on, turn off, and set channel. And the device interface defines all of the methods that a device should have. And currently we're just going to have these three methods. We're not going to worry about any other methods such as turning the volume up or turning the volume down. We're just going to keep it simple for now. So next up, we're going to create our remote control class. This is like our base remote control class. And remote control needs to be composed of a device. So we're going to say private device, and then we're going to pass a device into this remote control class via the constructor. Okay, so now we can define what a basic remote control should do. So a basic remote control, just like beforehand, if we go into our remote control from before, a base remote control can turn a radio on or it can turn a radio off. We're not going to worry about volume up and down for now, just to keep things a little bit more simple and short. So let's create first of all the turn on method. And in here we can just call device.turnOn because we know that all devices will have a turn on method. We can then create a turn off method and simply call device.turnOff. Okay, so this doesn't matter what the brand of device is, whether it's LG, Sony or Samsung, because it's coded to this device interface, we can just simply call these methods on the device without checking what the brand of device is. Okay, so we're using polymorphism here, which makes our solution nice and flexible. Okay, so let's just leave it as that for now, keep things simple. So let's now also create our advanced remote control class. Let's see. And this needs to inherit from our base remote control, and this should be we need to generate the constructor and pass the device up to our base remote control class. Okay, so the advanced remote is going to do everything that a remote control can do. So it's going to inherit our turn on and turn off methods, but an advanced remote can also set the channel. So let's add a set channel method. Okay, so you can see that an advanced remote can do everything a remote control can do, but it can also set a channel by passing an integer of the channel number. Okay, so let's now go ahead and create our devices, our sort of concrete devices. So first of all, we're going to create an LG radio device. So we're going to call this LG radio, and this is going to implement the device interface. So let's implement all of those methods, and you can see here that in LG radio we need to implement all methods from device. And it doesn't matter, we're not actually worrying about whether this is going to be an advanced device or a regular base sort of remote. The remote type is no longer related to the device. We control the sort of limitations of what we can do within these remote control classes. So in remote control we can specify that if we have a remote control we can only turn on or turn off the device, whereas if you have an advanced remote control you can turn on, turn off and also set the channel. and within these concrete device classes, we just implement all of the methods possible for any different type of remote. So now what I'm going to do is I'm just going to copy and paste these methods in to save some time, because all we're doing is, well, we're doing exactly as what we did previously. So we're just logging a few things out when we call these methods. So let's also create a Sony radio now. So a Sony radio device. And again, this is going to implement device. And I'm just going to copy and paste these in to save some time. Okay, so you can see that Sony devices can be turned on, turned off, and we can also set the channel. Okay, so now let's have a look at how a client would use this solution. So you can see previously, if we wanted to control an LG radio with a radio and TV remote, we had to create this very specific subclass. So this solution is going to be a lot different. So let's actually create an LG remote control. In fact, let me just comment this out so you can see the sort of differences a little bit more clearly. So first, let's create an LG remote control. And this should be a structural dot bridge dot good. Okay. So a remote control, you need to pass the device that we want to control. So the brand of device that we want to control is an LG radio. So we're going to pass an LG radio into here. And now if we call LG remote control dot turn on, and we can also turn the device off. So let's actually run this program, and you can see that that works correctly. So now we can see that we have two separate hierarchies. We have the remote type, which is separate from the brand or device type. Okay, whereas beforehand we were sort of combining them into subclasses. Here we have an LG sort of radio and TV remote. So radio and TV remote is the remote type, and LG is the brand. Whereas now we are creating a new remote control object. So the remote type we specify here, and then we pass the device that we want to control. Okay, so we've separated the two hierarchies and we've connected them using this bridge, this device bridge. Okay, so let's also now have a look at how we could create an advanced Sony remote control. So let's do that. So here we specify advanced remote. We're not saying Sony advanced remote. And then to make this an advanced Sony remote, we just pass the Sony radio device, or the sort of brand that we want to control. And then we can pretty much do what we did before. So we can turn on, we can turn off, and we can also, let's see, set the channel to some channel number. So if we run this, we can see that that is all working correctly. So now, as remote control, our remote control class is now delegating. Okay, you can see here it's delegating the work to the device via the bridge, and the bridge is basically composition. So the device hierarchy and the remote type hierarchy can now grow independently from each other. So now if we add a new brand of radio, we only need to create one new class. So our code is now more flexible and easier to maintain.